Hey everyone, welcome back to the lecture series of ICSE 10th Chemistry Mole Concept. This is a third video for mole concept. In the first video, we have covered the numericals based on Gay Lussac's law. In the second video, we have covered the numericals based on Avogadro's law. In today's video also, we will be covering some more questions from Avogadro's law. My name is Arpita Banerjee and you are watching Arpita Classes. So, in the previous video, I have already shared the concept which is involved for doing the Avogadro's law. If you have not seen the video, you can just type ICSE 10th Chemistry Mole Concept Part 2, where you can get the sums from the beginning along with the concept which is based on the Avogadro's law. So, there we have done 15 questions. Today we will be starting from question number 16. So, question number 16 says, calculate the mass of 2.8 liters of carbon dioxide. So, if you remember, I gave you four relationships, that is 1 mole of a substance is equal to molecular weight of the substance is equal to 22.4 liters at STP, and that is equal to Avogadro's number of particles. Okay. So, from those four relationships, we have to find out the mass, and 2.8 liters is given. That means we have to take out molecular weight and 22.4 liters at STP. So, we are going to write molecular weight of carbon dioxide is equal to 22.4 liters at STP. So, molecular weight of carbon dioxide is 44 gram. So, 44 gram is equal to 22.4 liter. Therefore, 2.8 liter corresponds to how much gram? X. Cross multiply, it is 22.4 x is equal to 44 into 2.8. Therefore, x is equal to 44 into 2.8 divided by 22.4. We can see there is point before one digit in the numerator and also in the denominator. So, we can simply neglect the point. It is 44 into 28 divided by 224. Now we can reduce it into the lowest term. So, you can reduce it by 4, 4, 7, 4, 5, 4, 6, 7, 1, 7, 8, 4, 2 and 4, 11. So, it is coming 11 by 2. I will write it here. It is coming 11 by 2, that is 5.5 gram. So, the answer is 5.5 gram. Calculate the mass of 2.8 liters of carbon dioxide. So, 2.8 liters of carbon dioxide weighs 5.5 gram. Okay. Let us see the next question. Okay. So, the next question is, calculate the volume occupied by 53.5 gram of chlorine. So, again they are asking for volume occupied, and they have been given 53.5 gram. That means again we have to take out molecular weight of chlorine. Molecular weight of chlorine is equal to 22.4 liters at STP. So, molecular weight of chlorine is 71 gram. So, we will write 71 gram is equal to 22.4 liters. Therefore, 53.5 gram is equal to how much volume? We will cross multiply 71x 53.5 into 22.4. Therefore, x is equal to 53.5 into 22.4 divided by 71. So, now if we calculate this, we will get the answer in liters. Okay. So, calculate the volume occupied by 53.5 gram of chlorine. So, we can get the answer in liters. We have to calculate and we will get the answer. I am not doing the calculation as of now. You can do the calculation and we will get the answer. We will move on to the next. So, we will start with the next question. The next question is, find the number of atoms in 192 gram of sulfur. Sulfur is S8. One molecule of sulfur, the formula is S8. We need to find out the number of atoms, so which is related to Avogadro's number, and 192 gram which is related to molecular weight. So, we will write here that molecular weight of sulfur molecular weight of sulfur is equal to 6.023 into 10 raised to power 23 number of molecules. Now molecular weight of sulfur will be 8 into 32 gram, because 32 is the atomic weight and there are 8 atoms in one molecule of sulfur. So molecular weight of sulfur is 8 into 32 and that is equal to 6.023 into 10 raised to power 23. Therefore 192 gram is equal to how many molecules? So from here we'll get how many molecules are there in 192 gram of sulfur. They're asking for number of atoms. So we need to multiply 8 with this answer, 8 with x, because here we are getting in 192 gram how many molecules are there. Since one molecule of sulfur contains 8 atoms, so these many molecules will be containing how many atoms. Okay, so let us first find out x. 8 into 32 into x is equal to 192 into 6.023 10 raised to power 23. Therefore x is equal to 192 into 6.023 into 10 raised to power 23 divided by 8 into 32. So this goes by 8 7, 8 3, 8 4. So it is coming 3 by 4 into Avogadro number. So these many molecules are there in 192 gram. Now we need to see how many atoms. So we need to multiply 8, because in one molecule 8 atoms are there. So in so many molecules, how many atoms are there? So I'll just wrap this part. Here I'll write number of atoms present in 192 gram of S8 is equal to 8 into this, that is 3 by 4 into 6.023 into 10 raised to power 23. So this will get cancelled, 4 2. So it is coming 6 into 6.023 into 10 raised to power 23. Now you can just simply multiply 6 and 6.023 and get the answer. So this is the answer, where 192 gram of sulfur contains this many number of atoms. This is the number of atoms. Let us see the next question, question number 19. Question number 19 is the number of atoms of potassium present in 117 gram of potassium. They have given potassium is 39, that means the atomic weight of potassium is given, that is 39. So number of atoms again which is related to Avogadro number, and 117 gram which is related to the molecular weight or atomic weight. Here our substance is potassium, so we need to take the atomic weight. So we'll write atomic weight of potassium, is equal to 6.023 into 10 raised to power 23 number of atoms. Now in place of particles we need to take atoms, because we are taking atomic weight of potassium. Potassium is an element and the smallest particle of an element is atom. So 6.023 into 10 raised to power 23 number of atoms we have to take. Now atomic weight of potassium is 39. So 39 gram is equal to 6.023 into 10 raised to power 23 number of atoms. Therefore 117 gram is equal to how many atoms? We need to cross multiply. I'll do it here. So it is 39x is equal to 6.023 into 10 raised to power 23. Therefore 10 raised to power 23. 39x is equal to this into 117. I'll write it little down. So it is 39x is equal to 117 into 6.023 into 10 raised to power 23. Therefore x is equal to 117. 6.023 into 10 raised to power 23 divided by 39. 39 into 3 will give you 117. So it is coming 3 into 6.023 into 10 raised to power 23. So when we multiply these two, we get the answer. They are asking for the number of atoms. So this many number of atoms is the answer. Okay. Let us see the next question, question number 20. Now the next question says, find the number of molecules in 1.5 liters of water and density of water is given. So volume of water is given and density of water is given. They are asking for number of molecules. So first of all, volume is given 1.5 liters. Since the density is given in gram per centimeter cube, so 1.5 liters we will convert it into centimeter cube. We know that 1000 centimeter cube is equal to 1 liter. So 1.5 liter is equal to how many centimeter cube? We just have to multiply this. So it will be 1.5 into 1000, that is 1500 centimeter cube. So we converted liter into centimeter cube. Why? Because the density is given in gram per centimeter cube. And the density is what? 1 gram per centimeter cube. So we know that density is equal to mass upon volume. So here, from here we'll get the mass. Mass is equal to density into volume. So 1500 into 1, that will give you 1500 gram. So we got the mass of water, right? Now we have to find out the number of molecules. So we know that molecular weight of water is equal to Avogadro number of molecules. Avogadro number of molecules. Now, molecular weight of water is 18 grams. So we'll write 18 gram is equal to Avogadro number of molecules. Therefore, 1500 gram is equal to how much? So now we need to cross multiply, get the answer and write it here. So 18 into x is equal to 6.023 into 10 raised to power 23. Therefore, x 23 into 1500. Therefore, x is equal to 6.023 into 10 raised to power 23 into 1500 divided by 18. 18 and 1500 goes by, we can take 6 in place of 6.023, we can just simply take 6. We can just approximate this little bit. So 6 and this will go by 3, 3 and this will go by 500. So it is 500 into 10 raised to power 23. This much approximation will work. Sometimes if the calculations are very big or very hectic, then you can just do this much of approximation will work, okay? So here number of molecules in this many liters of water is this. So basically what did we do? When we have the volume of water and the density of water, we found out the mass of water. So mass of water we got. Now we know 18 gram of water means this many molecules, Avogadro's number of molecules. So whatever mass came, that much water is equal to how many molecules? Let us proceed towards the question number 21. We need to find the number of hydrogen atoms in 0.25 mole of H2SO4. So our substance is H2SO4 and the smallest particle of a compound is molecule. So here it is, this many mole is given and number of atoms is given. So which two relationship we have to take it out? That is 1 mole of H2SO4 is equal to Avogadro number of molecules. First we'll get the molecules because the smallest particle of H2SO4 is molecule. They're asking for number of atoms, hydrogen atoms, that we are going to find out later on. So 1 mole of H2SO4 is Avogadro number. So 0.25 mole of H2SO4 is equal to how many molecules? Cross multiply, so we'll get x is equal to 0.25 into 6.023 into 10 raised to power 23 number of molecules. So we got in 0.25 moles how many H2SO4 molecule is there. Now we can see in one molecule of H2SO4 there are 2 atoms of hydrogen. So in these many molecules how many hydrogen atoms are there? So we'll write in one molecule of H2SO4 contains 2 atoms of hydrogen. Therefore, 0.25 into 6.023 into 10 raised to power 23 molecules of H2SO4 contains how many hydrogen atoms? 2 into 0.25 into 6.023 into 10 raised to power 23. So when you multiply this, you'll get this many number of hydrogen atoms. This many number of hydrogen atoms. So how do we multiply? We just multiply 0.25 into 2 will give you 0.25 into 2, that is 25 2s are 50. 0.5 into 6.023 into 10 raised to power 23. So just multiply these two and keep your answer as it is. This is the number of hydrogen atoms. Let us see the next question. Find the gram molecules in 21 gram of nitrogen. Gram molecules in 21 gram of nitrogen. So remember, 1 gram molecule is equal to molecular weight of the substance. Just remember this. 1 gram molecule is the molecular weight of the substance and 1 gram atom is the atomic weight of the substance. So 1 gram molecule, here your substance is nitrogen, so that is 28 gram of nitrogen. Nitrogen, the atomic weight of nitrogen is 14, so 14 into 2, 28 gram. Therefore 21 gram is equal to how many gram molecule? Cross multiply, 21x is equal to 28 x is equal to 21, therefore x is equal to 21 upon 28. 7374, 3 by 4, that is 0.75 gram molecule. Okay, so here we have learned one new thing, that is 1 gram molecule is equal to molecular weight of the substance and 1 gram atom is equal to atomic weight of the substance. Let us go for the next question. The number of atoms in 10 liters of ammonia. Number of atoms in 10 liters of ammonia. So that means they are asking for number of atoms which is related to Avogadro number and 10 liters which is related to the 22.4 liters at STP. So we'll write 22.4 liters at STP of ammonia, that is NH3, is equal to 6.023 into 10 raised to power 23 number of molecules. First we'll write molecules because the smallest particle of ammonia is molecules. So 10 liters is equal to how many molecules? First find out the molecules, cross multiply. 22.4x is equal to 6.023 into 10 raised to power 23 into 10. Therefore, x is equal to 6.023 into 10 raised to power 23 and 1 will give you 10 raised to power 24 divided by 22.4. So, these many molecules we get. Now, in one molecule of ammonia, there are 4 atoms. So, these many molecules contains how many atoms? So, you just can write down number of atoms is equal to, we just have to multiply by 4. 4 into 6.023 into 10 raised to power 24 divided by 22.4. So when you calculate this, you get the answer. How many atoms of ammonia are present in 10 liters of? Let us see the next question. We have to find out the volume occupied by 3.5 gram of oxygen gas at 27 degrees Celsius and 740 millimeter of pressure. So 3.5 gram of oxygen gas and they are asking for volume occupied. So we know that molecular weight of oxygen occupies 22.4 liters at STP. So first we'll do that. So we'll write molecular weight of oxygen is equal to 22.4 liters at STP. Right? So molecular weight of oxygen is 32 gram is equal to 22.4 liters. That means 3.5 gram is equal to 3.5 gram we'll write here. 3.5 gram is equal to how many liters? So first we'll find out the volume. X is equal to 22.4 into 3.5 divided by 32. So this much liter. Okay, we will not calculate this. Now see, they are asking the volume occupied at 27 degrees Celsius and 740 millimeter of pressure. Now we know that this volume is at STP. STP means standard temperature and pressure. In standard temperature and pressure, oxygen gas occupies this much volume. So in this temperature and this pressure, what will be the volume? So we have to convert it into, we have to use a combined gas laws. P1 V1 upon T1 is equal to P2 V2 upon T2. So here P1 is equal to standard pressure, that is 760 millimeter of pressure. T1 is standard temperature, that is 273 Kelvin, and in that V1 is this volume, that is 22.4 into 3.5 by 32 liters. At STP it is occupying this much volume. So when the pressure is changed to P2, that is 740 millimeter of pressure, and the temperature is 27 degrees Celsius, immediately convert it into Kelvin, because in chemistry we always keep the temperature in Kelvin, so it will be 300 Kelvin at 273 to 27. So we need to find out V2. So here we are going to use the combined gas laws, that is P1 V1 upon T1 is equal to P2 V2 upon T2. Now we have to put the values over here and we have to get the value of V2, right? So I'll do it here. So P1 is 760, V1 is 22.4 into 3.5 divided by 32, T1 is 273, P2 740, V2 we do not know, and T2 is 300. So V2 will be is equal to 300 into 760 into 22.4 into 3.5 whole divided by 740 into 273 into 32. So when you calculate this, you get the answer in liters. V2 will be in liters. Yeah, so we have reached to the last question, that is 25th question for today's lecture. The molecular weight of, we need to find out the molecular weight of 2.6 gram of a gas which occupies 2.24 liters at 0 degrees Celsius and 760 millimeter of pressure. Now when you say 0 degrees Celsius, that is 273 Kelvin, and 760 millimeter of pressure, that means it is the STP condition. Okay, so in STP condition, whatever mass 22.4 liters will contain, that is the molecular weight of the substance. Here we have to find out the molecular weight. So we will just write down that 2.26 liters weigh how much? 2.6 gram. Therefore 2.24 gram, sorry, 2.24 liters weigh 2.6 gram. So 22.4 liters weigh how much? Cross multiply, 2.24x is equal to 2.6 into 22.4. Therefore x is equal to 2.6, 22.4 divided by 2.24. First we'll remove the points. So here we'll write 26 upon 10, 224 upon 10, and here 224 upon 100, that 100 will go up. This 10, 100 will get cancelled, and 224 will get cancelled, so 26. That means the gas occupies 26 gram at, that means the gas occupies 22.4 liters of volume. 26 gram of gas occupies 22.4 liters of volume at STP. So the molecular weight of the gas is, therefore the molecular weight of the gas is 26. Understood? I'll repeat it again. They're asking find the molecular weight of 2.6 gram of a gas which occupies 2.24 liters at 0 degrees Celsius and 760 millimeter of pressure. That means 0 degrees Celsius and 760 millimeter of pressure is the STP condition. So we need to find out at STP condition what is the weight of 22.4 liters of the gas. Because whatever will be the weight of 22.4 liters of gas, that will be the molecular weight. So we did 2.24 liters of the gas occupies 2.6 gram. Therefore, 22.4 liters occupies how much? So that is, this is the weight which the gas occupies at STP, and 22.4 liters of gas occupies this much weight at STP. Therefore, it is the molecular weight, right? So today we have completed Avogadro's law. I have done 25 questions based on this Avogadro's law. In our next video, I am going to start with percentage composition. Stay tuned. Thank you so much.